Right, so we are going to do a similar experiment to last time, but instead of using a resistor, we're going to use a bulb, and the bulb is on your desk. We're going to use a big bulb, a 12-volt bulb. Okay? And you're going to plug it into the power supply that's on your desk. Wires are at the side of the desk. And you're going to have an ammeter and a voltmeter in there as well. Okay, so the setup will be something like this. Hang on a sec. So, wire from the power supply to the ammeter to the bulb back to the power supply, and your voltmeter, remember, is in parallel, so two separate wires from your voltmeter into the bulb. Okay. What you're going to do is, it's not the most scientific method, you're going to follow the instructions here. So, you can see here we've got a table of results, and it just says description of the filament. So when you turn that bulb on, when it's a low voltage, it might not be glowing, then just glowing, then red hot, orange hot, yellow hot, and white hot. So as you go through the voltages in your power supply, you'll see it goes from 2 all the way to 12. So 2 is going to be the lowest, 12 is going to be the hottest. Okay. So you're going to go through each one of those and write down the current and the voltage, and then work out the resistance using voltage divided by current. Then you're going to plot another graph, because I know you all love graphs, of voltage on the y-axis and current on the x-axis. And it should look different to the resistor one. So the resistor one, as Charlie said, was a straight line through the origin. This one will not be a straight line. It will be a curve of best fit. Okay. So it's a relatively straightforward experiment. You don't even have to have exact voltages, you're just moving the dial on the power supply. Any questions? No? Amy, do you want to join another group, or are you happy working on your own? It's up to you. I'll give you the choice. Right, off we go. Right, so hopefully we've all got our results, and they're sort of curved. Some people got slightly straighter lines than others, but we're looking really for a curve. It starts off shallow and gets steeper. Okay, remember what we said at the beginning of the lesson, resistance can be calculated by finding the gradient of a voltage current graph. So if the resistance was constant, the gradient would be constant. But because it's getting steeper, that means the gradient is increasing. So that also means the resistance is increasing as we go up the current and the voltage. So these are the questions that I want you to think about, and I put the answers there. So as the current flowing through the lamp increases, what happens to its temperature? Well, if you touched that when it was really bright, it would be very hot, wouldn't it? So as you increase the current, you're increasing the temperature of the bulb. What does your graph tell you about the relationship between voltage across the current and current through the lamp? Well, you can say as one goes up, the other goes up. That's still true, but it's not directly proportional anymore, because it's not a straight line through the origin. If the voltage across the lamp is doubled, what happens to the current flowing through it? Or if it's tripled, there isn't that same pattern as there is with a resistor, because it's not directly proportional. And does the resistance change when the temperature of the lamp is changed? And how can you tell from the graph? Well, as we said, as you increase the current, the temperature of the bulb increases, and the resistance increases. And if you can cast your mind back to when we started doing resistance, we said one factor that affects the resistance is temperature. So as that bulb gets brighter, it gets hotter, and therefore its resistance increases. What happens to the resistance of the lamp as the temperature increases? It also increases. So in conclusion, for a bulb, as you increase the voltage, the resistance also increases. And it's all about that temperature, so the temperature is increasing.